You know, I can already tell by looking at the answer choices here. I know what 22 is asking us. It's one of these questions that comes up once every test, and it's essentially just giving you a bunch of random mumbo jumbo, but ultimately it's just asking you to get r squared in this equation by itself. So let's rewrite this here, and I'm going to rewrite it in a way that I really recommend that you write, especially if you struggle with these types of problems. And I'm going to rewrite it as 4 times pi times r squared. I put it in capital because, let me put that r squared. I put it in capital just because my handwriting's bad. You don't need to necessarily put in capitals. Okay, and now I want to get r squared by itself. Well, one thing that I know is that when I'm trying to get like I have a fraction equal to a single term, I know that I can actually always swap these two terms. Okay, so I can actually rewrite this as 4 pi r squared, and the times by each other. There we go. Is equal to p over I. And I'll get into how that is true in a minute. But now that I get r here and I realize everything's being multiplied here, I can actually then divide both sides by, let me put a division symbol here so it makes more sense, by 4 pi. And that would cancel that out here. And then dividing by 4 pi here would be the same as r squared is equal to p over I times 1 over 4 pi. Remember, that's keep, change, flip, right? That's what we did here to write this. And we can already see that it's already looking a lot like b here. But what really brings it home is that we can just multiply our numerators. So p times 1, that just gives you p. And then I times 4 pi would just be I times 4 pi. And the fact that they're all being multiplied means that we don't even need to put these brackets ultimately there. It can just end up being b. Now, back to our original situation here. Why is it that I can always just swap these two out? Let's think of a simpler number, and then we can see how that works. Let's say that you had x is equal to 1 over 5. Or even let's think of a simpler number, 1/2. I can actually, I can swap out x and 2 and rewrite this as 2 equals 1 over x, because what happens really is, what would I do if I had to go about this the right way? Well, this is 1 divided by 2. What's the opposite of that? Well, you could say times 2. So that'd be times 2 over 1 times 2 over 1, right? And this would be over 1 here. So then you would have 2x is equal, and this would be canceled out, equal to 1. But what if I want to get 2 by itself? Well, then I would divide x here and divide x here. This would cancel out, and I'd end up with 2 equals 1 over x. Or essentially, remember, if we look back at our original problem here, if x equaled 1/2, like I said, you can just swap this and the denominator, this single term, and the denominator are interchangeable.